Assalamu alaikum. Bala, can you all hear me?
Yeah, loud and clear, sir.
Okay. Can you also see my screen?
Yes.
Yeah, it's visible.
Okay. So apart from those that I make co-host, Lukman and Bala, the others cannot mute themselves. So please, if you have any observation, question, or whatever, you can raise up your hand, and then Bala and or Lukman can unmute you so that you can ask. Because when I first joined, the background was a lot noisier, so I disabled that. So what we'll be seeing today is part of what you've started. So we are going to see like two presentations today. So the first is data distribution, visualization, and then proportion visualization. So it seems you've seen introduction to some form of visualization with Matplotlib, and also tomorrow we'll be seeing relationship visualization and also creating meaningful visualization. So today also is a part of introductory presentation with regards to visualizing proportions and distributions. So what you will be seeing today will regard the data, I think the BETS data set, but also there is another that is called the mushroom data set. So we'll be running the code in here. As you see, I just set up some of the code here on my local computer. So if you don't have these libraries on your computer, I think if you're running the experiment on Google Colab, these libraries will have been, or these modules will have been installed already there on the virtual machine that you are provided with. So if on your system, maybe part of the installation, if not done installation for Pandas, Seaborn, and Matplotlib, especially Pandas and Matplotlib, I know you should have them by now, maybe due to some of the previous lessons that you've gone through. So if you don't have them, you can install them using pip. But also in here, if you may see, you select my kernel, data science kernel. Yeah, so it's just an environment that I created to run most of my data science work. So on this kernel, if we may run this, you may see that all of these libraries have already been installed. So you will see that there is no output yet. If I will remove this -q so that it shows us that everything is already there. So you see, requirement satisfied. Every requirement has already been satisfied. So the -q is meant if you for making the output like not very cumbersome. So now we have everything that we need to run some of this code that we will be seeing. So seeing data sets. So ideally, if you're in data science, what you want to make out of the data is meaning. So sometimes you want to see how distributed is your data. So there might be a situation where your data set might be set is skewed. And what do we mean by skewed? That means maybe among some of your labels, among some of your classes in the data, some dominates others. So India, maybe even after you train any, if you're, let's say, developing a model that will kind of help explain the data for you or get meaning into the data for you, that dominant class might overshadow some of the classes. So sometimes you want to see how distributed your data is. So starting from this, what you want to see is first your data. You want to know how many columns the data. You can look at it like just opening it. If I may open here, there is data. In data, there is the best.csv. So if you see here, it kind of look somewhat very untidy. It doesn't even make sense. Here, row number 1 will tell you these are your column names, but you have to start even making sense what column names are or whatever. So the best thing here is to load the data set into a data frame, and we know Pandas enables us to do that. So you load them into a data frame and then you print the head. So usually head gives you back the first 5 rows in your data, including the columns if there are column names. If there are no column names, it will assume the first row also as a column. So we may see this. So first, let's import our libraries. After importing the libraries, we may print n. Here, we read bets using pd.read.csv because we are dealing with a CSV file. And then you see these are your various columns and these are the rows. So the various columns do have their own header and whatever. So, but there might be files where there are no header. So you may say header is equal to, header is equal to none. Meaning you are telling it there are no header. There is no header row in it. So if you print this, you will see that it will assume even the first row as also a row, not as header row. But if you leave it by default, it will assume that your first row is your header row. How about maybe there might be that it's not the first row, but it's the second row that is the header. So you see what happens? It will assume that this your first row is the header and it will use it to read it. But by default, your header is 0. There are situations where the header is not defined. So that means your file just start from black belly to whistling dog, then do whatever and the rest. So in there, you might say, before you start working, you will supply header names. So supplying header names in there, you have to tell it that header is equal to none, meaning there is no header, but now take this as your header names or as your column names and the rest. So, but this for the default, we have our data set, and the data set consists of 1, 2, 3, 4, 5, meaning you have five rows in it. So with 5 rows also, you can specify that you need only 1 row to be returned. Maybe you just want to see how your data is formatted. So you can just say you just need 1 row by specifying 1 in head, or you can specify any number you like, but by default, it is 5. So this, we've seen our data, we've seen what columns we have, what type of information is stored in that data file. So in here, you have the name of the bet, because we are dealing with bets, their scientific name, the category they are in, the order, the family, the genus. I think these are all, biological terms. But also there is the conservation status, meaning whether these animals are extinct or they are under some form of vulnerability, or least concern, meaning LC, meaning just like sheep or goat or cow. You know, these animals will never finish, even though every day we eat them, but they are there, so it's of least concern. There is their minimum length, the maximum length they can reach, their body mass, the minimum body mass and the maximum body mass. Then also their wingspan, because you're talking about birds, minimum wingspan and the maximum wingspan. So in this data, you can find some relationships which we will be seeing using this in this presentation using visualization. So in general, you can quickly look at the data. It's distributed by using scatter plot. So you've seen scatter plot, so we don't need to go, because it said as we did in previous lesson. So when you click on this to run this code, you are plotting a scatter plot between the maximum length and their order. So the order is this column and answer reforms or essay reforms or whatever. So there are different order names. We may, if I may write a small code here, we may say but dot order dot values dot to list, so that we can see them here, the different orders. Oh yeah, these are values, but we can say unique, meaning we want to print only unique names so that we know. Okay, dot unique. I think this will return an object. That's the order that you look at image. Let's see. Now. Yeah. So these are the orders that we have, meaning the unique things that we have, but also we can say now to list, so that we can make them as list objects. So you see this, I think we have 1, 2, but also let's show the total order that we have. Let's print the length. So we have 21 different orders. So there are different bets, but they are in this this separate order. So you see the various orders that we have, the unique orders that we have, and they are 21 in number. But this, I think, is something by the side. Yeah, I'll just put in. So, but ideally, what we just want to see is just a preview of our data. So if you plot it, you'll see these different things. Even though it doesn't make much sense, but then it will tell you that Karadiri forms or whatever you see, you can see their minimum is mostly between something around 20 to around let's say 80 if we are talking about kg. So, but it doesn't make much sense. So you will see other sort of visualizations along the way. But this is your scatter plot by order and their maximum length. So the maximum length they can reach and the order. So in a particular order, meaning Karad reforms, almost all of the bets are within this range of, let's say, 20, if this is 20 kg or 20 gram or whatever, to 80 grams. So in here, you can see that answer reforms is between somewhat like 40 or 35 to 80. So in here, you can see how how they are spread. So the next is just working with histogram. And most of us here, we've done histograms in our secondary schools. We've done bar chart, pie chart, histogram, line chart if you did for Damas especially. But also in our universities, we did some form of this if we did physical sciences. So you can plot the body mass to determine how many bats are some certain range, because usually histogram gives you range. So in how do we call it, group data, you plot histogram to infer some information. So what happens here is you take your, if you take your body mass and you plot the histogram for it, it will I think by default is the bins, number of bins are 10, meaning you are drawing 10 bars, if we may call it bars in bar chart, but in here you call it bins. So it will draw 10 bins, and for each bin, it will represent a certain range of body mass. So if you are drawing for 10, let's assume we are not given this number of bins, so we can ask it to plot. So if you count the number in here, you see that there are 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you've created 10 bins in this histogram, and it will tell you from, let's say, 0 as 0 kilogram in the body mass, in the column maximum body mass. So from 0 to something like if we call this to 2000, so let's say 1,500, they are about more than they are about more than 350 beds that can reach 0 to, let's say, 1,500 kilogram. So, but in here, sometimes this might be that the data set is very much more compact, and you want to see as granular the information as possible. So you can increase the number of your bins so that the range will reduce. In here, we say the range is from 0 to 1,500. If we may approximate this as 1,500, it will give you 1 bin. And then from 1,500 to, let's say, 2,500 or 2,800, it will give you another bin. So, but it might be that the data is too much and then it's very much more compacted. So you can increase the number of bins. We said by default, the number of bins is 10. So if you can say bins is equal to 10, or you can just leave it like that, it will give you bins. And then the figure size is the size of the diagram that you uploaded, or the figure you uploaded. So now we increase the number of bins to 30. If you see, your chart or your bin will be smaller because you want to include as much as 30 bins from 0 to the maximum. So you will see, instead of having, if we compare this diagram with this, instead of having the range to be from 0, let's say, to 1,500 or 1,600, it's now 0 to something that is even like about 500. So by increasing the number of bins, you will know actually how many birds are within this range. 300 and let's say here can be 350 if we may, no, 350, but 330. So they are from 0 to, let's say, 500 kg. You have about more than 300 birds that can weigh that maximum span. So if you see, if even this information is much compact that you will like, you can also increase the number of bins so that you will see. But also the next one, you can plot. Here we are plotting this histogram on the entirety of the column called maximum body mass. Why not? Let's say minimum body mass also. Minimum body mass, and draw this for minimum body mass. So you see, you have an entirely different histogram because you are dealing with a different column. So we can select a range. We can say now because if we look at this, we can see here is 0 to 500, and it constitutes almost the majority of the classes in it. So we can say, how about plotting for a specific range? So plotting for a specific range, you can then filter your data frame, the best data frame, where you give it the condition of the filtering. So the condition of the filtering here is the bird's body mass must be greater than 1, because you cannot have a 0. So if you have even a bird that is weighing, let's say, a paper, that paper will have a weight. So it will not have 0. So meaning the maximum body mass greater than 1, but less than 60. So you are looking at something like, let's say, your chicken, your cock, your whatever. So those small animals. So you want to plot this for these small animals that weigh less than what you are having here. So from 0 to 1,000, let's take this as 1,600 is represented by here. But then you don't want to plot for everything, so you can filter. You can select from 1 to 60, meaning greater than 1, but less than 60. You can specify less than or equal to or whatever. So you just want to see, like, from this certain range, how is this looking on my histogram? So here you select the filtering. You select the filtered data, and we may see if we look at this, instead of just plotting, we can ask it to print the length of this data frame. Or let me take this suggestion. We take the length of the bats and the length of the filtered before filtering, before plotting, sorry. So we can click on this to determine. So ideally, the number of data points in your data set is 443. But those that satisfy this criteria, meaning they are between 1 and 60 kilogram, are only 193. So, but we may also see, because here we said it's between 0 and let's say 500. So they are about 300, let's say, and 50. Oh, no, not 350, but 300. Yeah, 300 plus, because it's 50-50. So we can increase this 60 to be that we are including 500 from this range to somewhere this range. We are assuming that this range is 500. So let's run this, and we'll see we have 319, and 319 is around this place. So you see your range is matching the maximum length that you get, that the histogram plotted. So it's around this. So we may safely assume that this is about 500. So including this, meaning we've increased it from 1 to 500. Let's now plot our histogram. So you will see even within that, we said from 1, if you see it's not on 0, but from 1 to anything before 500, it's plotting. So even at this, you see that we have most of the bets that we have in the data set are bets that are less than 70 kilograms. So you see in here, you are having some form of like, which of the bets are most dominant in your data. By just plotting this histogram, you are seeing that here, most of the bets are not that heavy, and then followed by what sort of bets, and that, and I think, and so on, if I may call it that. So you see, these are some of the distributions within your data set that you are trying to visualize. First, you started by plotting to see which of the classes is the most dominant, or which of the range of the minimum or the maximum body weight is most dominant. So you see that the range is within, or the most dominant belts are within 1,000 and 0 and 1,500 kilogram. Then in there, we dig deeper into the data set so that we know it says 1,000 to 1,500, but is it all of those 1,000 to 1,500 that are that big or that are that small? We increased the number of bills, and it told us that it's not all of them, but from 0 to 500, those are even the most dominant, because it can be, it told you that it's from 0 to 1,500, but then maybe it's between 600 and 1,000 that are most dominant within that range. But since they are all within that range, they are put in together. So as like an aggregate data that you will see that here, that's the most dominant class. So after increasing the number of bins, it will now reduce the range, and then you will start having like an idea on which of your data set is, or which range, or which range in occupy most frequency. Then you start seeing, so since I saw that it's between 1 and 500, so why not let me just plot for only this bar, meaning from 0 to 500, this bar. Now let me expand it. So you see, you are visualizing your data, you are seeing the distribution. Most of the distribution are along here, they are not that much. Most of the distribution is within this. Like most of the bets that we will be working on its data is between 0 and 1,500, but then also is between 0 and 500. So now let's see between 0 and 500, which one then also is the most dominant. You see is between 0 and let's say 20, you have about 70 bets in there between, let's say, 0 and 20. So if you like, also you can say between 0 and 20, now plot the graph for me or plot the histogram for me. And you see now you are visualizing your data. So if there are things that maybe you may say, I'm excluding this in the data because at the end of the day, maybe it will affect my analysis of the data, you may take that decision afterwards. But just having a data that just looks like this, if we is the data, the data that just looks like this, you don't even know what it means. So it's something like a kind of what should I call it? Something that is not, that doesn't have any particular shape or form. It's just data. So that's why sometimes with visualization and with everything, if a person, let's say, is generating data from their company and you as a data scientist, what you first do when you are given that data is to try to make sense into the data. But how do you make sense into the data? By first looking at the data. And how do you look at the data? You start visualizing. So do you need to plot just a bar chart or a pie chart or a donut? Or do you want a scatter plot so that you see maybe how the data, if let's say it's a clustering problem or you want to find out the relationship about those data, you might say, yeah, let me just scatter plot so that you see whether it's just cycling around a single place. You might say, yeah, this data is this or this data is that, or you just plot a histogram to find the distribution within the data, like, and the rest. So these are some of the things that we see. So if we may go on, I think the presentation is taken. So you see what we are just going down. So in here, you can also create a 2D histogram to determine the relationship between several columns in your data. So it can be that here you are developing or you are creating a 2D histogram between, in here we see the maximum length and the maximum body mass. So how, if it reaches, let's say, 50 kg, how often does it reach 200 kg? Because some bets might just be that they are long, but they are not that heavy. While some bets means that if they are getting longer, they are getting heavier. So this is it. So you might say, yeah, let me plot a 2D histogram, because whatever histogram that we've seen plotting, we are considering on only maximum body mass. And we are seeing the distribution only within maximum body mass. But you may want to look at how the relationship also between maximum length and maximum body mass, such that you know also the distribution where your data is most skewed. So if we may plot this histogram, as you will see here, you'll see that most of your bets are within this. I think you should have, yeah. So most of your bets are, your y-axis is the length, and your x-axis is the maximum body weight. If you like, you may put in before the plot PLT, you can give it the name of the axis so that it appears in the diagram. That you take it as a challenge or as a homework or assignment, where you try to label give it a title, give it the labeling of the x-axis and the y-axis. So most of your bets are within this range, meaning from 0 to 10, if we may put centimeter, because we are talking of length, and they are, and those bets are between 0 and if we may call this 50. So you see that, and also, sorry, the color scheme here gives you like which has, or which is the most dominant. So in here, like this yellow is the most dominant, and then this black or whatever here, if we call it dark blue, is the less dominant. And it goes like from one extreme to the other extreme. So it's getting like a lot, so this is the most dominant, followed by this, let's say followed by this, then followed by this, and then there are some by the side, and there are some that are just 0. Yeah. So this will give you also an idea that this makes up majority of your data. So also there we've seen the relationship between two columns in your data, the maximum length and how it relates, or how it relates also to the maximum body mass. And you plot in a histogram 2D. So histogram 2D is plotted by, you have your fig and then your axis, and then you plot subplots of tight layout. There are different parameters here that you may pass in your subplot and also your histogram 2D. So the best way to learn all of this is first go to Matplotlib, look at their subplot module, and then see the various type of subplots that you can build in. And then try to experiment. Maybe this might not be the best option of viewing this. It might be, it might not be. But then how do you find whether it is? By experimenting with several other diagrams or representations. So histogram work well by default for numeric data. So how about if you need to see the distribution for textual data? So it might be that there are a lot of Abdul or there are a lot of Muhammad in BUK. So, or there are a lot of Ibrahim in ABU. So all of these are textual data. And then you want also to visualize them. Here we said we plot scatter plot, we plot histogram on data set that is numerical. But in there, you might have situation where your data is textual, and how do you plot or how do you visualize such data? So usually you count also statistics in there. And how do you do that? There are guides also here. So the data set here includes good information about bird category, genus, species, and conservation status, and the rest. So as we said, when visualizing data previously, there is this conservation status, which is LC, but there is also endangered, extinct, least concern, near threatened, and vulnerable. So you see, these are all textual data for this category, genus. What we've been looking at are minimum length, maximum length, minimum body mass, maximum body mass, which are numerical data. But we also want to find some of the information here. We want to make sense of all of this categorical data. So these are text-based values, so you'll need to transform them to create a histogram. So, and how do we transform? We can transform them into conservation status and the rest here. Okay, so we filter, and so here what we do is we count, because birds is filtered birds, and then you get where the status is extinct. Sorry. Where the status is extinct, where they are CR, what is CR? Critically endangered, and the rest. So all of this. But also some of this data, you see we created all of this by hand. But if you like, you can automate the process, meaning you can get the lists of, if I may go down here, some of this coding is better, because sometimes you might make a mistake that you start, that you may start, so if I may copy this, sorry for deviating from some of this coding. So I may say my filtered bets, I can say conservation status is equal to filtered, where is filtered bets, dot conservation status dot unique dot to list, meaning I have this conservation status, and then I might say, yeah, so I can click on this and then print. You see we have least concern, not whatever, not near threatened, this. So you see we have created this column already, or this data set that we are trying to find. But also we can create a list. So we can say for C in CS, we can create a list of filtered bars is equal to, let's say, this. So for C in CS, what we are trying to do is FLB that we can call append, and then we can paste this. So pasting this, what it does is it will take a C and replace it here. C and replace it here, or we are plotting by this. So at the end of the day, if we can print this, and then we can go like this. So yeah, I will set X1 and so yeah. Oh, sorry. No set output. So this dot location, get this. We are adding this. Yeah. This is a set of. I'm sorry for making your life somewhat difficult. Yeah, and then this, we can call it this. So, and then now we print. So you see this things that you put in, but also here we can call it this maximum wingspan, this. So you see, this is the same thing as what's happening here. And then at the end of the day, we can just include them to draw. So yeah, so these are coding that you may try to just go around, and because you've done 30 days of Python, so some of these things you can do. So at the end of the day, what you just do is you just pass them, you convert them into whatever and you pass. But yeah, this is by the by. Let me delete this so that you don't get confused. But yeah, you make sure that the data here is matches the unique data, the unique label that are in the conservation status. So you get 6 data points, and in those 6 data points, you have some set of data frames. So, but even I think what we did before were set of data frames that you can just get them by indexing, and then you pass them here, and then it will plot whatever you want. If I may say Control MZ, no, or if I may say Control Z. So instead of appending this, I can say yeah. So maximum wingspan, and let's assume I'm not. So in here, so you have just 6 of these data frames, because this X1, X2, X3, X4, whatever, they are all data frames. And at the end of the day, you can plot something like this, having your quarks and whatever. But let's see this first. So now we've plot our histogram, and it's telling us that there are like near threatened here. You see the color code, if I may put it, or whatever. So there are some that are least threatened. There are also a lot of them that are of least concern. So you see, you've drew a histogram of this data, and especially most of the data that you do is data set here that are of text value, not numerical, because you have extinct, critically endangered, extinct, and whatever. So you are plotting. Before, we just plotted between numeric and numeric, but now we have plotted between a textual and then numeric, because the minimum wingspan, as we see here, is just is a numeric data. So the minimum wingspan, seeing the range between 0 to 10, there are about 10 of them that are of least concern. Those that have the minimum wingspan of about 70, there are about 20 of them that are of least concern. So These are some of the things also that you can visualize with data set that is textual. So then there are density plot. So you may notice that histogram are stepped and do not follow smoothly. So it's just like you are starting from here. I think there are situations even in maths where you start plotting from this, or maybe you get the middle on each, then you plot here, join here, then join here, then join here, like this. So you see you are plotting some sort of line chart here that will fit in this data. But then you can do that easily using density plot. So density plot, to do this, that's the essence of us installing Seaborn here. So you install Seaborn and then you run density plot. Bala, I'm coming. So here you can run your density plot on the minimum wingspan so that you can see it. Yeah. So this is the distribution that you have. Instead of having bar chart that will just look like bars, and then you'll be stepping, you try to approximate a line that fits in this bar chart. So this is so you can also plot for the maximum body mass also, where you can see also how it looks like. Ideally, before you will see a bar chart, but if you approximate the midpoint of those individual beings, sorry, histogram, I'm saying bar chart. If you approximate the midpoint of those bins, you will see that it will look at like something similar to this. Sorry, yeah, Bala, what?
Yeah, there was a question in the chat. Somebody was asking, how do you determine which visualization tool to use for a set of data?
Yeah, so this comes with experience. So as I said last week, I don't know especially what you did last week, but you started having some form of introduction to visualization. So, and at the beginning of this presentation, it said that you did scatter plot. So some of this, you just try using a different sort of visualization to see what best capture your data in such instances. So I was saying, if you want to, like, let's say, approximate how the data set relates to each other, you can do scatter plot such that if you have most of the data maybe around a single point, then you say, yeah, this data to some extent can be either categorical, depending on how what shapes that or what patterns you could visually see in the data. But there are data set that you just want to find out the distribution, meaning, yeah, I have this CSV file and it's telling me that they are beds. So I want to see like how much distribution are in these beds, because I know there is body mass. So if there is body mass and there is mass maximum and minimum, most of these beds, like what is their weight? So I might say, yeah, let me draw a histogram, and that histogram will tell you that between this certain range to this certain range, the beds are this in number. So in there, as I said, we can then go deeper to see actually which sort of range or which sort of categories are we looking at in your data set. So there are different information that you may inquire from the data of certain relationship that you want to see from the data. Then you might say, yeah, let me choose this visualization over other visualization. But also there are sometimes, if it's experience, when you are given some sort of data and maybe you are just told that this data is about this. So you have your go-to visualizations. So those go-to visualizations will give you a basic idea about it. Maybe maybe along the way, you may need more complex visualization, but you start from somewhere and then you start making meaning into it. Maybe until at the end, you bring about a more complex visualization about that data. So yeah, so here you can plot in your density plot. using Seaborn. You can adjust the bandwidth size. So the smaller bandwidth size, the more it looks like the midpoint, because here you see it's somewhat like a midpoint in your histogram. Here is somewhat like a midpoint. So trying to do that. So the more the bandwidth, the more smooth your line is. So you can explore also doing several bandwidths in it. So also you can beautify it with some explanatory visualizations. So in here you see you are given maximum body size, the hue, meaning the coloring, or the coloring, you are specifying it on order. And we saw that I think we have about how many orders? Yeah, some orders in there. Sorry. Sorry, I just received a call. So there are some so you can plot several density chart based on order as your hue. So it will plot severally for you, and also you can specify that it gives you a legend. So you can see the different coloring indicating different orders. So also you can plot a contour, meaning you look at So you can map also the density of several variables in one chart. So you can map between text length and minimum length of a bed compared to their visualization. So you see, you can plot for X as the minimum length and Y as your maximum length, and then the hue, meaning the color coding, is based on their conservation status, which we know there are about 6 conservation status, but maybe in here we choose in only 4, or it drew 4 for us. So we can just go down here and run this as the last. So you see, there are about 6 here, which here it shows 4. So we have 6, and all of these 6 have been drawn. So, and why is it like a contour? Because you are looking at it in a 2D direction, a 2D representation, such as, let's say, your contour if some of you did geography, you can find, like, given a map with its contours, you can draw the mountain, if we look at it as a mountain. So in here, it gives you the relationship also between maximum and minimum length based on their conservation status. So this is the first part of the presentation. I don't know, Bala, do we have time to look at the second? Because this is 4 already here, which is 3 in Nigeria, so it's 1 hour. But already.
Yeah, we have like 11 minutes, sir, to make it 1 hour.
Okay, so in that 11 minutes, do we answer questions, or do we just go through the order? Or I think the other part of it, you may look at it yourselves. Let me.
Yeah, we can be able to make it like let them run it practically as an assignment. Let's see,
Yes,
if somebody was having a problem.
if you may do that, yeah. So visualizing proportions, yeah. So here, visualizing proportion is using the mushroom data, and I think all of you should have this data by now. Is it, Bala? Do you all have this data set?
Yeah, I think we have it.
Okay, so since you have this data set, you see here you have majority is just textual data, but that textual data is mainly categorical. So in categorical, meaning these are poisonous, these are edible, these are edible, these are poisonous. But some are convex, Bell, and convex. So you see these are categorical data. All of it are just categorical. So we don't have anything numerical about whatever. So you can get the column names, which I think you can project it on by, after reading the data frame, you can then look at the head, meaning to see the various columns that you have. You can also use mushroom.columns. I think mushroom.columns will also give you the column names, but you can say select the data types of type object in mushroom and then print its column names. Yeah, so getting the column names here, you can select mushroom column names is equal to column names as category. So, and you then group them by class and count. So this counting is telling you, like, if you have things that are edible and poisonous, because we have only two classes in this. There are mushrooms that are poisonous and there are edible. So edible meaning you can eat and then you are safe, but poisonous meaning if you eat, you need prayers. So you get your class data, which is this. You group them by class, meaning those that are edible, how many are cap shape? How many are cap surface? How many are cap color or cape color? Or how many are bruises? So here you see, you take your data set that is basically categorical and you make some meaning by counting the number of instances where it satisfied that class. So most of it here you see, there are 4,208 that are within this class. So you see, you've counted them. So most of them are, if they are edible, it's just, yeah, they are edible or they are not. So, and if they are edible, they are just edible. If they are poisonous, because you have two categories, so there will not be overlap in that. But you can have overlap in cap shape. So let's say you do grouping by cap shape and then you count. There might be flowers that if you see, they are poisonous, but they are convex. They are edible, but they are also convex. So you see, there can be overlap here. But here, if mushroom cannot be poisonous and then also edible. That's why you see the number here like being all through unique. So if they are edible, everything here is just unique, and then you count the number in there. If they are poisonous, they are poisonous. But if you group by, let's say, the cape shape, and then you count, you will see that some of these numbers will not be matching these numbers, because there are instances where they also, if they are cape shape, the cape shape are this number, but then they also overlap in others. So you can try doing this grouping by cape shape, or grouping by cape surface, or grouping by cape color, and then you try to imagine what will then be the statistics in here. Because if you run this code, the only thing you will be doing is to changing this column name. After changing the column name, and then you click on the run here, you will see the numbers will change, and then you determine some of these overlaps in there. So, and after then, you can draw a pie chart to determine how many are poisonous or how many are edible. You can see a pie chart, meaning it says that 51% of them are edible, while 48% are poisonous. So you see, you have two classes, because you have only edible and then poisonous. And then you are drawing, in the edible class, you are drawing the against the population. So the population here is 4,200 and this is 3,096. So also here you can play with, but I think you will have the same diagram because all of the numbers are the same. Yeah, so, but as I said, by playing with the classes, you'll be finding that this diagram will be changing, because as you plot in, or as there are overlaps, the statistics will be changing, and then you'll be seeing. But also there is donut. So donut is a special form of pie chart, where what you do, you just add a cycle in it, such that here you find something that is very, very good looking. So you create the center cycle by plotting a cycle, meaning you tell the cycle it starts from the middle, 0,0, meaning it starts from the middle, and then the radius of the cycle is 0.4, 0.4. So it goes like this big, and then its fill color is white, meaning the fill color of the cycle. So you can try different fill color, and then on the figure, you can plot that, get the current figure. So the current figure is your pie chart. Then you just put in your get current axis. So you get current figure, it gets your pie chart. Then get current axis dot add artist, meaning you are adding a center cycle in your pie chart. You are fixing that center cycle in it. Without this center cycle, it's just normally your pie chart that you know. So here you are fixing the white in there such that it makes it a donut. And now you just put in your title and you plot. So also there is waffle, and to do waffle, you have to install the PyWaffle class. So as you see here, it's just also using waffle, you can plainly see the proportion of cap colors on the mushroom data set. Instructively, there are many green cap. So here is just like you are seeing your mushroom, actual mushroom, you put them together. So here you are seeing a lot of green mushrooms, a lot of yellow mushroom, white cap mushroom. You give it the colors that you want. So you have brown, tan, maroon, pink. You can play with all of those colors and whatever. So at the end of the day, you can see it's just like you plant mushroom in your farm, and then you are visualizing those mushrooms such that here you can see that there are more, what should I call this, maroon mushrooms than brown mushrooms, or there are more maroon than green mushrooms and the rest. So here it looks like a plantation. So you see a waffle. So this is like a very short presentation that we just fixed in the first presentation. So here it means that we have finished the presenting for this week, and then I may stop sharing the screen and then look at, yeah, so Bala, what do we have?
Nothing for now, sir, but I don't know if the fellows have a question. They can raise up your hand so that we unmute them to speak.
Yeah. So if you do have question, please raise up your hand, and then we will try as much as possible. If we can't answer, if we don't know, we say we don't know, and then the question will make us also to go and know. And we like altogether. So it seems we don't have any question, is it? We have one hand.
Okay.
Oh, no, it's a tap, it's a clap. So if not for the data camp task, I could have said this is too much for me today. What is too much for you? Is it the presentation or the number of things covered, or?
Maybe the visualization is much for him, but data have even covered some other aspect.
Yeah, so yeah, and that's how you learn. It's like very, 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 very easy. You just practice, and after practicing, you see that it's very simple. Try to get as much data set as possible, either from Kaggle, from some data set are even available either on Zenodo, Hugging Face, if I may say, but especially, yes, Hugging Face, Kaggle, Zenodo, you can get a lot of data set where you just make it your task to just be visualizing this data, to see how they look, to try to make meaning. Because most of machine learning or deep learning models find a relationship in data and then try to extrapolate maybe situations where it has not seen. But even yourself, you may just look at the data based on the visualization and say, yeah, this is it. You can just give an opinion on that data by just looking at it. Or by saying, yeah, why don't we just maybe change this? Maybe after changing this, we may find something like this or like that or whatever. So yeah, Sharif. You can unmute yourself. Bala, what is the deadline for the assignment?
It has to be on Thursday, sir.
Sharif, you can unmute yourself. Sharif is not here. So I think we've come to the end of the presentation. The video will be available for everyone. And if there are things, this is like an introductory part of visualization. So much of it you learn by practicing, by seeing a data set, how they look, what's the distribution, what's the relationship in between. Maybe some of the, because we said you can look at the relationship between their wingspan and maybe their conservation status, but also their maximum length and their maximum body mass. You can look at all of those relationships. So in between the data, and in between the different features in the data, you can look at all of these relationships. So, and you get better when you practice on the real world data sets. So without much ado, Lukman, do we have anything to add?
No, sir, you've said it all. It's all about practice. So the more the practice, the better we get. Sir.
Yeah, definitely. Bala, do you have anything to add?
No, sir.
Okay, so we meet tomorrow, inshallah.
MashaAllah. Thank you, sir.